An example program using structs. To understand when we might want to use structs, let's write a program that calculates the area of a rectangle. To understand when we might want to use structs, let's write a program that calculates the area of a rectangle. We will start by using single variables, and then refactor the program until we are using structs instead. Okay. Let's make a new binary project with a cargo called rectangles that will take the width and height of a rectangle specified in pixels and calculate the area of the rectangle. Listing 5-8 shows a short program with one way of doing exactly that in our project is src/main.rs. Listing 5-8 calculating the area of a rectangle specified by a separate width and height variables. Now run this program using cargo run. This code succeeds in figuring out the area of the rectangle by calling the area function with each dimension, but we can do more to make this code clear and readable. This code succeeds in figuring out the area of the rectangle. Area function and then width and height. Okay. So this code succeeds in figuring out the area of the rectangle by calling the area function with each dimension, but we can do more to make this code clear and readable. The issue with this code is evident in the signature of area. The area function is supposed to calculate the area of one rectangle. But the function we wrote has two parameters, and it's not clear anywhere in our program that the parameters are related. It would be more readable and more manageable to group width and height together. It would be more readable and more manageable to group width and height together. It would be more readable and more manageable to group width and height together. That's true. We've already discussed one way we might do that in the tuple type section of chapter 3 by using tuples. Refactoring with tuples. Listing 5-9 shows another version of our program that uses tuples. So you tuple rect and tuple. Okay. In one way, this program is better. Tuples let us add a bit of a structure, and we are now passing just one argument. But in another way, this version is less clear. Tuples don't name their elements, so we have to index into the parts of the tuple, making our calculation less obvious. Mixing up the width and height wouldn't matter for the area calculation. But if we want to draw the rectangle on the screen, it doesn't matter. We would have to keep in mind that width is the tuple index 0 and height is the tuple index 1. This would be even harder for someone else to figure out and keep in mind if they were to use our code, because we haven't conveyed the meaning of our data in our code. It's now easier to introduce errors. Refactoring with struct is adding more meaning. We use wait a second. Mixing up the width and height wouldn't matter for the area calculation, but if we wanna draw the rectangle on the screen, it wouldn't matter. Mixing up the width and height wouldn't matter for the area calculation. But if we wanna draw the rectangle on the screen, it wouldn't matter. We would have to keep in mind that width is the tuple index 0 and height is tuple index 1. I don't get it. This should be even harder for someone else to figure out, and keep in mind if they were to use our code. Because we haven't conveyed the meaning of our data in our code, it's now easier to introduce errors. Refactoring with struct is adding more meaning. We use structs to add meaning by labeling the data. We can transform the tuple we are using into a struct with a name for the whole as well as names for the parts, as shown in listing 5-10. We use structs to add meaning by labeling the data. We use structs to add meaning. We use structs. We use structs to add the meaning by labeling the data. We can transform the tuple we are using into a struct. We can transform the tuple we are using into a struct with a name for the whole as well as names for the parts. Rectangle for main, let rect1, rectangle width 30, height 30, println area rect. Fn area rectangle U32 rectangle width rectangle height. Defining a rectangle structure. Here we will define the struct and name it rectangle. Inside the curly brackets, we define the fields as width and height. Inside the curly brackets, we define the fields. Both of which have the type U32. Then in main, we create a particular instance of a rectangle. We created a particular instance. We created a particular instance. We created a particular instance of rectangle that has a width of 30 and a height of 50. Then in main, we created a particular instance. Then in main, we created a particular instance of rectangle. We created a particular instance. We created a particular instance of rectangle that has width 30 and 50. Okay. Our area function is now defined with one parameter. Our area function is now defined with one parameter which we've named rectangle. Our area function is now defined with one parameter. Our function is now defined with one parameter. Okay, makes sense. Rectangle, which we've named rectangle, whose type is an immutable borrow of a structured rectangle instance. Immutable borrow of a structured rectangle. Okay, makes sense. Immutable borrow. As mentioned in chapter 4, we wanna borrow the structure rather than take ownership of it. This way main retains its ownership and can continue using rect1. Main retains its ownership and can continue using rect1. Makes sense. Which is the reason we use the ampersand in the function signature, in the function signature, and where we call the function. The area function accesses the width and height fields of the rectangle instance. Note that accessing fields of a borrowed struct instances does not move the fields values, which is why you often see borrowed structures. The area function accesses the width and height fields of the rectangle. The area function accesses the width and height fields of the rectangle instance. Note that accessing fields of borrowed struct. The area function accesses the width and height fields of the rectangle. Okay. Instance. The accessing field so borrowed struct instance does not move the field's values. Which is why you often see borrowers of structures. Our function signature for area now says exactly what we mean. Calculate the area of a rectangle. Using its width and height fields, this conveys that the width and height are related to each other, and it gives descriptive names to the values rather than using the tuple index values 0 and 1. This conveys that the width and height are related to each other, and it gives a descriptive name to the values rather than using the tuple indexes. Okay, this is a win for clarity. Makes sense. Adding useful functionality with the derived traits. It'd be useful to be able to print an instance of rectangle while we are debugging our program and see the values of all its fields. Listing 5-11 tries using the println macro as we have used in previous chapters. This won't work, however. Listing 5-11 tries using the println macro as we have used in previous chapters. Won't work, however. When we compile this code, we get an error with this core message. The println macro can do many kinds of formatting, and by default, the curly brackets tell println to use a formatting known as a display. Output intended for direct and the user consumption. What? It'd be useful to be able to print an instance of rectangle while we are debugging our program and see the values of all its fields. Tries using the print macro we will have in previous chapters. Print rect one. The println macro can do many kinds of formatting, and it throws an error. Okay. The curly brackets tell println to use a formatting known as a display output intended for direct and indirect end user consumption. Direct end user consumption. The parameter types we've seen so far implement display by default. Oh, okay. Because there's only one way you do want to show a 1 or any other parameter type to a user, but with structures the way println should do, format the output is less clear because there are more display possibilities. Do you wanna commas or not? Do you want to print the curly brackets? Should all the fields to be shown? Due to this ambiguity, Rust doesn't try to guess what we want, and structures don't have a provided implementation of a display to use with the println and the braces placeholder. If we continue reading these errors, we will find this helpful note. Help the trait CDFMT displays are not implemented for a rectangle. In format strings, you may be able to use blah 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 blah. Let's try it. The println macro call will now look like putting the specifier colon question mark inside the curly brackets that tell println we wanna use the output format called debug. Oh, the debug trait enables us to print out struct in a way that is useful for developers so we can see its value while we are debugging our code. Compile the code with this change. Threat, we still get an error. Rectangle doesn't implement debug. But again, the compiler gives us a helpful note. The trait debug is not implemented for rectangle. Derive debug to rectangle or manually import debug rectangle. Rust does include the functionality to print out debugging for information, but we have to explicitly opt in to make the functionality available for our struct. But we have to explicitly opt in to make that functionality available for our struct. Rust doesn't include the functionality to print out debugging format information. Rust does include functionality to print out debugging information. Rust does include functionality to print out debugging information. Okay. But we have to explicitly opt in to make that functionality available for our struct. To do that, we add the outer attribute hash derive debug just before the struct definition. Adding the attribute to derive the debug trait and printing the rectangle instance using debugger formatting. Now when we run the program, we won't get any errors, and we will see the following output. Now when we run the program, now when we run the program, now when we run the program, we won't get any errors. Now when we run the program, we won't get any errors, and we'll see the following output. Right. Nice. It's not the prettiest output, but it shows the values of all the fields for this instance, which would definitely help during debugging. So here, like practice. Okay. When we have larger structures, it's useful to have output that's a bit easier to read. In those cases, we can use colon hash question mark instead of colon question in the println string. In this example, using the style will output. Another way to print out a value using the debug format is to use the dbg macro. Okay, which makes ownership of an expression as opposed to println that takes a reference, which takes ownership on. Okay, print is the file and line number of where the dbg macro call occurs in your code along with the resulting values of that expression and return the ownership of the value. Here's an example where we are interested in the value that gets assigned to the width field, as well as the value of the whole structure in rect1. Here's an example where we are interested in the value that gets assigned to the width field, as well as the value of the whole structure in rect1. Macro occurs where the print is a line number where the dbg macro occurs in your code along with the resulting value of the expression and return the ownership of the value. Owner's print is note calling the dbg macro in print is the standard error console stream as error as opposed to println, which prints the standard output console stream. We will talk more about SCR in the writing. Error message to standard error instead of standard output. Here's an example. Here's an example where we are interested in the value that gets assigned to the width fields, as well as the value of the whole struct in rect1. Rect1 here. Struct rectangle. We can put dbg around the expression. 30 times the scale, and because dbg returns ownership of the expression's value. We can put dbg around the expression 30 times the scale. Oh, here, dbg 30 times scale. And because dbg returns ownership of the expression's value, the which field will get the same value as if we didn't have the dbg call there. We don't want dbg to take ownership of rect1, so we use a reference to rect1 in the next call. Here's what the output of this example looks like. 30 times the scale is equal to 6, and then rect. Okay. That makes sense. We can see the first bit of output came from line 10, and where we are debugging the expression 30 times the scale and its resulting value is 60. The debug formatting implemented for integers is to print only their value. The dbg call on line 14 of src main.rs outputs the value of rect1, which is the rectangle struct. This output uses the pre-debug formatting of the rectangle type. The dbg macro can be really helpful when you are trying to figure out what your code is doing. The dbg macro can be really helpful when you're trying to figure out what your code is doing. The dbg macro can be really helpful. The dbg macro can be really helpful when you're trying to figure out what your code is doing. The dbg macro can be really helpful when you're trying to figure out what. Okay. In addition to the debug trait, Rust has provided a number of traits for us to use with the derive attribute that can add useful behavior to our custom types. In addition to the debug trait, Rust has provided a number of traits for us to use with the derive attribute that can add useful behavior to our custom types. Those traits and their behaviors are listed in Appendix C. We will cover how to implement these traits with the custom behavior as well as how to create your own traits in Chapter 10. There are also many attributes other than derive. For more information, see the attribute section of the Rust reference. Our area function is very specific. It only computes the area of rectangles. It would be helpful to tie this behavior more closely to our rectangle struct because it won't work with any other type. Let's look at how we can continue to refactor this code by turning the area function into an array method defined on our rectangle type. Our area function is very specific. It only computes the area of rectangles. It would be helpful to this behavior more close to our rectangle struct. It would be helpful to tie this behavior more closely to our rectangle struct. It would be helpful to tie this behavior more closely to our rectangle struct because it won't work any other type. Let's look at how we can continue to refactor this code by turning the area function into an area method defined on our. Okay, makes sense. Area function is very specific, only computes the area of rectangle. It would be helpful to tie this behavior more closely to our rectangle. Okay, makes sense. Determine the professor. Okay, rectangle, derive here, and then rectangle, so area rectangle1. So rectangle1 was consumed by this method here, and this won't work because of this here line 14. Mm, yes. What is the difference between display and debug threads? Display is for cases where a value has a unique string representation, while debug does not assume that. Display is for printing values to the console, while debug is for viewing values in a debugger. Display cannot be implemented for structs, while debug can be implemented for structs. There is no difference. Display and debug are aliases for the same trait. Um, I think this is opposite. Display is for printing values to the console, while debugging is for viewing values. Display cannot be implemented for source where the debug can be implemented for source. I think this one. Boom. Oh shit. Set of correct answers. Display for cases where a value has a unique string representation, while debug does not assume that. Mm, wait a second. Roster include functionality print putting the print section perform debug. The debug thread enables us to print out print our struct in a way that is useful for developers, so we can see its value while we are debugging our code. Okay. Hmm. Display for the cases where a value is a unique string representation, while debugger does not assume that. Okay.